Hey guys, very quick update. You can see it's been running for a long time here now, probably close to an hour. The only reason this one has any reading on it right here is because of this LED here. I had on for a little bit. It's a scope shot. But here, it's gonna bounce around a bit, the camera, because that motor pulses. I need both hands to hook up this LED here. I'm gonna hook it up. It's a 5 watt, 12 volt LED. Just gonna hook it directly to the motor. Here, slow it down just a little bit. It's pulsating, but it's really bright. That's the inputs. This is the side of the motor I hooked it up to. The other side's still not registering because it's such a low consumption of power going in. Take it off of there again. Put it on. Back on. Something here real quick. Hook it back up to the killer fed. It's hooked up again. So now we'll take the positive of this LED. Oops, off. Such small wires. This without shorting anything out with one hand. Hook it up to the battery. There. And we'll put it through the meter, right? There you go. It's 4 watts to run it. That's including the motor, which doesn't use much. Back up. See, it's almost as bright, just that it's flashing now. Seen with this bridge rectifier circuit, the power, I'll have to draw it out, it'd be a lot easier to explain, but like the power is able to go directly out of the FET into the bridge rectifier without going through the motor. So that's why, like, if you were to charge, take like a 24 volt battery and hook the output to a 12 volt battery with this circuit, you'll probably fry the circuit unless you have a really big FET that can handle all that current. But I doubt it. And the bridge rectifier would have to be able to handle it too, because it does go through the bridge too. That's the only thing you gotta know with this circuit. Eventually I will do a schematic of that circuit. It's really simple. Like, even the way it is right now, like, these batteries hold somewhere around 330 watt hours or so. So it would run for 700 hours with that light on. If you put a capacitor on there, it would smooth out. Or if you just hook the light directly to it, you have 5 watts being used, so difference. I just wanted to share that. Simple experiments. I don't know, there's probably about, the ramp has $185 worth of magnets on it. The 2 extra magnets on the rotor over there, probably, remember, maybe $10 for the 2 of them, not even. Those are just cheap Chinese ones. There were 7.5 pounds of copper on this when I started. I don't know what's left now. That's how much copper I use. There's 200 turns per coil. Each ohm out at 3 ohms. 2,400 turns in total. The magnets on the rotor, cheap Chinese magnets. The bottom ones are these shitty ones. They're not very strong at all. They're not N52s. These are probably the 35 grade. N35. They're pretty weak. And the top wire is these smaller ones too, which are just some cheap Chinese ones. Probably $50 total for magnets on the rotor. The circuits probably cost $5 to build, both of them together. Cost the most in this is the wire and the batteries. BMS's. Yeah, really good results though. It's just a low power input results. When you ramp up the voltage, the power going in with these systems, it goes up drastically. This one probably be able to handle a couple 100 volts, especially with the way it's being pulsed. These transistors would have to be changed though. Bridges would be fine. And probably have to put a higher value resistor in here. And going to the Hall effects. Those would have to be changed too. But right on. I want to say thanks for watching. Appreciate it.